Hello and welcome. My name is Lloyd Chunga from Zuzu University ICT Incubation Center. In this video, I'll be walking you through the project that we're working on, which is known as MiLab. MiLab is a game-based learning application that enables MSc level secondary school students to conduct virtual experiments in physics and chemistry. The goal of MiLab is to engage students in free, safe, and unlimited virtual experimentation, especially for students in the rural areas who might not have access to traditional laboratory facilities. To understand our solution, let's look at the background of our project. In Malawi, every year, MSc exams are administered, which include practical exams for physics and chemistry. These practical exams require technical ability and knowledge that comes with frequent experimentation and practice. This arrangement presents us with three major challenges. The first one being that most students do not have access to lab facilities at their local schools. The second one is that even for the few lab facilities that we have, most labs are unequipped and inflexible. In addition to that, the congestion in labs reduces the quality of delivery of content. It is because of these challenges that we conceived the MiLab idea. Our solution is to develop an application that simulates a range of physics and chemistry experiments in 2D and 3D. The app has got an interactive gameplay directly tied to the MSc syllabus learning objectives. The game presents students with different scenarios that they can learn through mistakes and repetition. In addition to that, the game has got an ability to assess students' performance. So, how does the community stand to benefit from this solution? To begin with, MiLab offers blended learning. This solution does not intend to replace the traditional laboratories, but rather complements them. In this way, students can enjoy the benefits of both the traditional laboratories and virtual laboratories, thereby improving teaching and learning experience. Secondly, there's less strain on traditional laboratory facilities. MiLab delivers comprehensive details on physics and chemistry practical lessons. This removes pressure on schools and students who might not have access to traditional laboratory facilities. Furthermore, there is a safe learning environment with MiLab. This is because students are not exposed to the health hazards that are associated with traditional laboratories. In addition to that, the content that is shared by MiLab is safe and clean. Last but not least, MiLab offers free access to virtual laboratory 24/7, allowing for unlimited access to experimentation. We have recently completed the primary prototype of this solution. So without wasting much time, let's walk through the demonstration of the prototype.
Hi, my name is Vision Tondoya and I am with the ICT Incubation Center. Today, I will be demonstrating the MiLab prototype that we have currently. There are different types of simulated modules within the application. These include modules in physics, modules in chemistry, lab safety rules, as well as modules on general lab apparatus and reagents. This prototype consists of two modules. One is a chemistry experiment on determining the strength or weakness of an acid or base using universal indicator solution. And the other is an interactive lesson on how to use a Bunsen burner in a lab environment. Let's start by taking a look at the latter. The Bunsen burner lesson falls under the apparatus and reagents section, where students can explore a range of apparatus and reagents that are likely to be found in a typical Malawian laboratory. When the student selects the Bunsen burner lesson, they are presented with a screen that consists of different objects that the student can manipulate in a guided process of safely lighting up a Bunsen burner. Here, the game instructs the student to completely turn off the air hose slider while slightly turning on the gas valve slider before switching the gas on in order to create a safety flame. This follows the real-world process of turning on a Bunsen burner safely. The student then goes on to adjust the air hose slider in order to obtain a stronger light blue flame, as well as adjusting the gas slider in order to obtain a larger or smaller flame. All the while, the temperature of the substance in the beaker continues to rise as indicated by the thermometer shown on the left-hand side. In this way, we can teach students how to use certain apparatus and reagents safely before they encounter them in a face-to-face situation. As I mentioned earlier, another module that is covered by this prototype is an experiment on determining the strength or weakness of an acid or base using universal indicator solution. This is a basic experiment that introduces students to the concept of acids and bases. This module belongs to the chemistry simulations section. When the simulation is opened, the student lands in a 3D space that is a simulated laboratory environment. The first step is for the student to set up the apparatus and reagents that are required for this experiment. This is done in a search and identify manner where the student double taps on the apparatus that he or she thinks will be required for this experiment, in reference to the apparatus that are displayed above the screen. To make it more challenging and interesting, the student only has a limited number of moves for setting up the apparatus. Once the apparatus are successfully set up, the student proceeds to the experimentation desk where they begin the experimentation process. This takes us to the second step of our simulation. This step involves filling out precisely 20 cubic centimeters of predefined chemicals into respective beakers. The student uses the drop-down menus to match each chemical with its corresponding beaker label. For instance, the chemical acetic acid can only be poured into beaker number 1. If a match is made, the student can fill the beaker with its corresponding chemical. When all beakers are correctly filled, the student then moves on to the next step. The third step involves placing droplets of universal indicator solution into each beaker with its respective chemical. In the real world, when universal indicator solution is dropped onto any substance, the mixture produces a different color that indicates the pH of the substance. The strongest acids produce a red color, while the strongest bases produce a violet or purple color. This simulation follows the same logic, displaying different color changes for the different chemicals that the student worked with in this experiment. The student then matches each color change with its corresponding pH value on the pH scale. The observed results are recorded and analyzed on the analysis screen. In conclusion, among a range of other functionalities, students can use this app to familiarize themselves with different lab apparatus and reagents, as well as conduct different experiments in 2D and 3D environments. We are very optimistic about our solution and its potential in making a difference in education. However, the project faces challenges that are hindering its continuation. Our main obstacle is the lack of resources to support development activities. These activities include upgrading our development environment software and hardware, recording of voice guidance for inclusiveness and accessibility, field requirements gathering, module development, as well as other development-related activities. With adequate assistance, this project will run its efficient and transparent course and ultimately produce a digital solution to teaching and learning which benefits the community immensely. Thank you very much for watching our video, and we look forward to your feedback. Goodbye.